Hi guys, well, it's been a while since my last video, so I thought it's time for another one. And I know these videos probably are not the most successful ones, but again, they have to do with vintage electronics. But this time, how to maintain or repair vintage electronics using modern components. And taking as an example, this power supply is what you see here. It's an DEC digital H7440, 5 volt 25 amps, not really powerful, 125 watts. And this comes from a digital DEC machine, PDP-11 60. It's a huge machine, not a huge, it's a big old computer, mid-70s. Last time that I saw these ones or similar ones was in the 80s, 1985, in the University of Vienna for, I don't know, a few months till we switched over to April 3. But anyway, big things. I would never thought that I would have to do with this oldies, let's say so. If a good friend of mine was not a collector of vintage computers, and these vintage computers turn to have the tendency to die, and most of the power supply, everything that has to do with power electronics has the tendency to decay, degrade, die at the end. And I'm repairing all this stuff for him and making the one or the other new design if there are components that are completely obsolete or inobtainium or whatever. So anyway, blah blah. This video is in how my approach is on swapping these big capacitors that you see here from this power supply without changing almost nothing on the overall construction of the power supply, so to keep it as period correct as possible. So, of course, this is a controversial discussion, controversial theme, because when we come on electrolytic capacitors, we have here quite a few different opinions. The first thing is you have the absolutely purist, no, not the purist, you have the guys that say, no, this stuff will never die. It's just so good, even if it is 50 years old, you know, a 50-year-old human decays too. But anyway, they mean no problem, this will work. And we will let that is what is inside the original one till it fails. So what? Okay. Have much fun with that. If it fails, it can be from a catastrophic to a cascaded fail to just blowing the fuse. But you have all this spectrum that can happen. The second ones are the purists that say, I do not want to change I want to keep it one-to-one period correct as possible. So I want, if we change it, to have exactly the same caps. And there is where the problems start. The big blue one, you still can get it from Vishay, yeah, and Mauser, etc. Costs 50, 60 euros or something per piece. But the small one is a 31 millifarad at 50 volts. But the small one, nobody is making those anymore. It's a 6,000 microfarad at 10 volts. You know how a 6,000 microfarad, 6,800 microfarad at 10 volt looks today? A fraction of this. And the problem is the screw terminals. So if you don't want to change anything on the PCB to start soldering and doing this stuff, this is not an option. So for today, I will show you my solution. I presented the owner of this computer with 3 solutions. First of all, do nothing and wait till it fails. Second, let's do it as period correct completely using these capacitors, but this one is available. I found it only on eBay, but what sense does it make to change an NOS capacitor that is again 50 years old with another one? These things, as you can see here, have a date code of 77, same as this big Bertha here, date code 77, so it's 50 years, yeah? And the third option is to just replace these things, these capacitors, with a modern solution that is available for a long time to come, but without changing the character, the mechanicals of the power supply, and to make it possible to reverse these mods if needed and wanted without any issues. So, and this is why you see at the back the PCBWAY box that came, because I made a solution with PCBs, and I want to show you a little bit more how it looked when these capacitors were in this PCB, in this power supply itself. So this is how the power supply looks from the inside. Interesting construction. You have the 2 switching transistors and the flyback diode. This thing is nothing else than a very old, one of the first, or the oldest one that I had in my hands, buck converters, step-down converters. Low frequency switching and efficiency no more than 50%. Here you have the AC rectifier diode. How they work, the PDP-11 60, at least the one that I saw, has a bus voltage, an AC bus voltage between 20 and 30 volts. There is a huge transformer inside that supplies all these power supplies. And this one have the rectifier and the smoothing capacitor inside. That's the primary side of the 30 volts. And this is how the capacitor was situated. I cannot put it now completely inside to see, but this is how it was mounted. And this one is the outgoing capacitor, the output capacitor, 6000 microfarads, 10 volts. And you see it is already, anyway. And with screw terminals, and was screwed on these 2 pads. Same thing, this one has again screw terminals and was screwed on these 2. On these 2. But these ones, the only change that I made in this power supply is to bend these lashes, these contacts here, these contact lashes, as you can see here, to 90 degrees, nothing else. So if you want to make it to reverse the change, just carefully bend it back, and that's it, and then you can screw it like that. So these are the changes what I made. The whole design is based on PCBs. So let me show you the first one. And here is where PCBWAY comes to play. Thank you very much, PCBWAY, for the nice PCBs again. Of course, immaculate quality as always. And let me show you. The first one are the ones that I made for the smaller capacitors, for the smaller capacitor. And it looks like that. That Let me show it even greater, bigger, nicer. I adjust. I mount 4 1800 microfarad capacitors, low ASR capacitors in parallel to form the capacity that was before 6000 microfarad is now 6200 something, yeah? At 16 volts, or I don't know what I used. And this is how it looks. I used 10 volt ones, anyway. The diameter of the PCB itself is the same exactly as of the capacitor, and the diameter of the mounting pads, or the mounting holes, or whatever you call them, are the same, 10 millimeters. I'm using here aluminum standoffs with an inner thread of M5. Interesting thing is that at the capacitors, the thread is metric, M5. All the other screws on this power supply are imperial. That's a little bit a pain, yeah, because even more in a country where we are used in metric and not an imperial. It is we are not used to deal with that, yeah. So that was for me something new, to deal with screws 4-40 something and 632. Honestly, this didn't tell me anything, yeah. I have to acclimatize on that. Anyway, this is the first one. This is how it looks. Just screw it in place of this one, and that's it. And the second one is this one. This is the big one, the Big Bertha one, where I have 3 pieces of 10,000 microfarads at 50 volts, and one with 1000 microfarad at 50 volts to have roughly 31 millifarads. Of course, the design, the electronic design, was primitive, yeah, nothing really special. The only special is that I used double the copper than it is normal. Thanks again, PCBWAY, for that. As you can see, beautiful PCBs. And I opted to have the nuts soldered on the back. This has 2 reasons. First of all, the electrical contact, much better. And secondly, it's much easier to mount this thing from the above without having to hold the nut from the bottom. Of course, I could use standoffs, SMD standoffs with an M3 thread, but these are 2.5 euros per piece. So I opted to this solution, yeah. The most of the work that I had to do was mechanical work. And for that, I had to make a few mock-ups, a few possibilities. The first one has been dismissed because I thought I will use different mountings. The second one was not optimized. At the end, I used the third one. So I printed it on paper, glue it on a cardboard to have a stability, and made the holes so I can test it in real, yeah. The thing is that I had to find a solution to make this thing stable and to mount it in a way that I do not make new holes or I do not change the casing of the power supply itself. And the idea was, when I take the power supply again. At the right side here, as you can see, there is a long screw. This wasn't a long screw, it was a screw that just was mounting the PCB to the casing. I replaced this screw, made it a little bit longer, and we are using a standoff here. That's an M3 because the M3 the diameter is a little bit larger than the 4-40, so it works perfectly. So let me show you how the whole thing looks mounted. In between, let me show you the next PCB, of course from PCBWAY. Really, really nice. You know, it's not something very special, but the silk screen, the ink, everything that is inside is much more sturdier than on other suppliers. This is why I prefer a lot PCBWAY, even that there are a few 1 or 2 years more expensive, but this thing is worth it. It does not scratch that easy. It is very sturdy. Anyway, this is how it looks. Again, thanks PCBWAY. By the way, you can check their website. PCBWAY is not only producing high quality PCBs, they make PCB assembly, as I showed in the past too, because I made 2 PCB assemblies with them. 3D printing and mechanical metal job. I will put a link in the description. Give them a try, take a look of them. I have quite a few of my designs on their shared project page. I will put the link of my projects, my shared projects at PCBWAY on the description link too. Anyway, if anybody is interested, yeah, I can provide information or perhaps put it on the PCBWAY shared projects page. So this is how it looks. Very, very nice. Just a few more details. This is how it looks without the capacitors, just with the nuts attached. Well, this is how it is. Anyway, just for stability, I added these 2 adjacent holes, so it is possible to use a cable binder to mount it, and I will show you how. But this is the most important one, the most important mounting feature. Okay, let's put it together. This is how it looks mounted. Both PCBs. Let me show it a little bit closer. See how we can do it. This is how it looks. It is already completely sturdy because of this metal piece that was used to hold this big capacitor. Yeah. And again, we're out of focus. Let's get it again. This capacitor. Again, 77 date code. And this is how it looks, the second small PCB. For the second small PCB, I used the original screws, M5, because they are a little bit lower than the ones that I use for the connectivity here. So you see, this is the only change that has been made on this power supply, and it is completely reversible if necessary. Nothing else has been changed. The whole thing is here. I want to put perhaps a self-locking nut. If I found a 441, because I don't have these things, I have only metric stuff. And then we have here, this thing is a little bit tricky, this stuff, because it was mounted like that it is on an angle. As you can see, it is not straight, it's on an angle. And I want to use a distance ring, a distance holder, a plastic distance holder of 3 millimeters, and to have it in that way because it doesn't interfere with anything, yeah. And it makes it easier for me not to scratch the PCB and not to connect it, not in any way to have a problem eventually to touch one of the ground rail. As you can see, I made here a line that should be the border of this one. Yeah, now you can see the holes, why I made the holes, because here there are cutouts and I wanted to use them to mount the PCB even more sturdy with cable binders, small cable binders directly on the holes, but honestly not necessary. This thing holds like a bomb. It's like concrete, yeah. As I said, the only thing that has to be changed, and I want to change, is instead of screwing it like that and having it, for my taste, a little bit too near to the copper, but it's still 1.5 millimeter away. But anyway, it's easy. But for that, I have to use a longer 632 screw that, of course, I don't have, yeah. And I ordered those on AliExpress, and when they came, I will use them. So, I don't know if you're interested, but I will give you a little bit more information about how these things work. As I said, it is an early step-down converter, controllerless. That means there's no dedicated controller for this switch mode power supply. We are using here 2 switching transistors, quite old ones, 250 watts, 200 watts capable, TO3 packaging. And here we have the buck flyback diode, but unfortunately I have no datasheet, and I cannot find any datasheet on the net. So if you have any datasheet about this diode used here, NSR 8117, please send it to me. Current sensing is done with these 2 resistors. You have two fuses, a big one, a slow blow 25 amps, and another one, where is it? Here. This small thing here, it's again a 15 amps fuse. Is it 15 amps? I think it's a 15 amps fuse. So, this is the grow bar thyristor for the voltage protection. This is the series diode to this thyristor. If this fires, it blows this or this, hopefully, fuses. But anyway, this is not that fast because the fuse, this is a slow blow one. So just relying on that, it's not really enough anyway. Imagine if this part here dies or is completely dry out. First of all, you can have a lot of ripple, and then you have phantom symptoms on your pricey computer that you want to restore, or in the worst case, you destroy the CPU or anything else. Anyway, this is the reason why these capacitors at this age, if somebody asks me to give me my preference and a suggestion, change it. Would be interesting what you say. I'm sure that we will have controversial answers, but this is my solution, and this is the solution that the owner wanted too. Because at the end, the owner is the one that decides. Either leave this stuff as it is, if it looks okay for the moment, let it as it is and wait to fail, or change this stuff with just new ones, but that look exactly the same. That is a problem because there are not many companies that making them still. Vishay, for example, has them at Mauser with I think 50 or 60 euros. But this one is a problem because I never found one that is newly made in this packaging. So, and I would never buy one from eBay that is NOS, that's again 50 years old, just to change a 50-year-old capacitor with another 50-year-old capacitor. Really? No. So, my solution, this and this. Well, I don't know what to say more. As I said, all the PCBs are from PCBWAY. Of course, in the always immaculate and perfect condition. Now, let's have a look on testing this thing. Starting with 6 amps and going full up to the 25 amps. And now the proof of concept, the test of the two PCBs, the primary one with 31 millifarad modern capacitors, and the output PCB with 4 pieces of 1800 microfarad low ESR capacitors that never existed at that time when this thing was built. Let me show you here. At the moment we have 6 amps. Output 5 volt, 5.4 volts is 32 watts here. And the input voltage is 28, 29 volts. I'm using this Variac here because it's the only powerful thing that I have that can give more than 10 amps from the primary side. So let me show you what happens. Yeah, primary, nobody sees anything. Primary current, AC current is 2.5 amps. At 6 amps secondary, this is a very bad efficiency. Anyway, let's see. Okay, I will turn it again off. Let's continue getting up. You hear the transformer? It's getting bad. So now let's reach the maximum. That's the maximum that this power supply can or should deliver. 25 amps, 5 volts. We have 26 something, almost 27 volts primary. And look at that. Primary current is 10.4 amps. Well guys, this is getting warm. I don't want to keep it all too much longer. The switching transistors and mostly the flyback diode of the buck converter, because this thing is a very early buck converter, very, very inefficiently designed. Everything is like antennas, but anyway, it's mid-70s and it works. Wow, this thing gets hot too. The bridge rectifier. What about the transformers? Nothing. Zip. Nothing. Let's turn a little bit lights on. Yep. Of course, this is a very Russian construction, but it's just for a single test. Still I have the connectors here that I'm missing. 125 watts, 25 amps, 5 volts. 10.5 amps primary, current at 26.7, let's say 27 volts primary voltage. So let's continue. Well, that was it for today. I hope you liked it. If you like my videos, if you like my content, if you like what you see, give me a thumbs up. Press the notification button to get informed when I have a new video, and please subscribe my channel. This will help me to grow a little bit more the channel. And guys, almost 70% of you are non-subscribers. It doesn't cost anything. Subscribe, it's free, and it helps me a lot. And give me a thumbs up. So, thank you again, PCBWAY. A description in the links for PCBWAY, the website and the shared projects site will be in the description. Thank you very much for watching. Stay safe, my friends. Till the next time. Cheers.